I'm Nadia Konechny. I'm enrolled in Mosumi Munmun's Cyber 332 course at Metropolitan State University, and I'm going to talk about authentication and authorization in modern web applications. So, first of all, this video is solely for educational purposes, and the creator is not liable for any damages that could be caused by using these demonstrations. So first, we're going to talk about authentication versus authorization, the differences. So authentication is for like signing into an application. It's about verifying the user's identity, that they are who they claim they are. So the question here is like, who are you? An example would be showing your ID at the front desk of a hotel, where the staff has to confirm your identity and then will hand you a key card. And examples of authentication would be, like the classic example would be passwords. There's also biometrics, SMS codes, and various other methods. We'll be looking at WebAuthn on how they make this process more secure than traditional passwords. And then authorization is about what a user can do. So going back to the hotel example, it's once you're given that key card, the system doesn't care about who you are, your identity. It cares about what your card can open and what it can't. So this is about like permissions and whether users have access to specific resources. So examples would be role-based access. OAuth 2.0 allows API scopes, giving like single sign-on permissions to apps would also fall under authorization. Okay, so the big problem with authentication and authorization in web applications has been traditional passwords, which have um, which act as shared secrets. So they're vulnerable to phishing attempts. Either the user or the server can be compromised. And so either like a user could fall for a phishing attempt or a website could experience a data breach. And in either case, the user's password is compromised. Traditional passwords also come with issues around human error because just humans in general, are not good at remembering like very large series of random strings of 16 characters or more. So we tend to choose like simpler passwords. We tend to reuse passwords across services, which then opens us up to credential stuffing, which is where passwords are stolen from one site and can be used to breach others with via automated attacks. Which could lead, for example, to like if you have an account on a small hobby website and you use the same password for your primary email or bank account, then if this hobby website gets compromised, then your other more important accounts will get compromised as well. Passwords also have issues with accessibility barriers, where a lot of the time there's like high complexity requirements, at least to have like a secure password. And meeting these requirements can create accessibility barriers to people who will have a hard time remembering or keeping track of a large number of passwords. So all of these issues have encouraged the industry to move towards passwordless alternatives, which can be easier for the user, but harder for an attacker to steal remotely. So we have two modern solutions that try and address this. And as far as, so web authentication would address like the password issues specifically with authentication. And OAuth 2.0 is more aimed towards authorization issues. Web authentication, or WebAuthn for short, aims to minimize the need for password logins. Is sometimes talked about the end of the password era, so that instead of having to remember complex strings of characters, WebAuthn can use the hardware on your devices and protocols, for example, with a thumbprint scanner or Face ID to minimize the user having to memorize um, a shared secret. And the core tech behind this is public key cryptography, which is asymmetric. So like a user will generate a public key and a private key in a handshake between the two, and the private key never leaves the user's device, so it's impossible to phish for this password. OAuth 2.0 handles permissions, so authorization, the primary goal being secure delegation and third-party access. So this is what lets you, for example, like sign in for a new website or to use a new service and just sign in with your Google or GitHub login instead of having to create a new account, create a new password, and then keep track of those. And they accomplish it through bearer tokens, which are created when you authenticate, access a service, and then refresh periodically to keep track that you are who you say you are and have those permissions, which can be revoked at any time. Okay, so going more in depth on WebAuthn, the going passwordless option. So instead of having a shared password, we use public-private key pairs. So the flow here is when you register an account, your device will generate a unique pair of keys, a private key and a public key. The public key will be sent to the server, which issues a random challenge to the user, which the user's device then signs using its private key and sends back. The server then uses a public key to verify that signature, which means the private key is never transmitted over the internet, and the attacker has no way of accessing it. One important feature of WebAuthn is origin binding, which can be created, means a credential can be created for a specific website and be cryptographically tied to that domain so that if an attacker then tries to send like a phishing version of the site, the browser will catch that the domain doesn't match and will refuse to sign the challenge through WebAuthn, which addresses a lot of vulnerabilities with remote phishing, where an attacker would try to pose as a website to phish for passwords. WebAuthn can also leverage platform authenticators like Windows Hello or Apple Face ID, which allow for biometric authentication so that users don't have to handle typing, which can be helpful in terms of accessibility. Okay, So OAuth 2.0 comes in once we've authenticated a user and are determining what we can do as that user. So OAuth 2.0 is used for secure delegation, which is when one app accesses data from another without having to share your password. Um, Traditionally, this was done with bearer tokens, as mentioned before. But anyone who can access the bearer token can then get access to delegation and authorization, which makes them a vulnerability. OAuth 2.0 has been moving towards PKCE, in addition to bearer tokens, which is proof key for code exchange, which ties when the app starts a login process, it creates a temporary code, which when it then asks you for the bearer token, it has to prove it knows the temporary code as like an additional secret handshake on top of the bearer token being transmitted. So even if an attacker gets access to your bearer token, they aren't able to use it for themselves. Another rising technology is sender constraining technologies like DPoP, demonstrating proof of possession, which is used to cryptographically bind a token to a specific device. So if an attacker on another device does steal your bearer token from local storage, they aren't able to use it because they're not on your hardware. OAuth 2.0 also handles issues of like scope for authorization and least privilege to ensure apps only get permission to data they need. And like as an end user, you'll see this like allowing or declining certain app permissions. Um, and then finally, as far as accessibility concerns, single sign-on has a lot of potential benefits for accessibility because users don't have to manage like a large number of different passwords and like actually handle that regularly, which reduces both the chances of user error, making sign-ons more secure, as well as being more accessible. All right, so to wrap things up, we've seen traditional passwords are no longer enough to protect modern web applications. By moving towards a passwordless model with WebAuthn, we can eliminate risks of phishing and credential stuffing through asymmetric cryptography. OAuth 2.0, meanwhile, allows us to manage permissions across the web with more granular access control and single sign-on. Um, Newer developments and technologies like PKCE and token binding make bearer tokens more secure and mitigate damages if a token's intercepted. And finally, we've seen that strong security design and accessibility are not at odds. And by implementing like modern latest protocols and technologies, we both improve our security and can improve accessibility.